Welcome, and thank you for joining. Today we will be discussing how to protect your game servers from DDoS attacks. My name is Sean Mark. I'm a manager on the DDoS Response Team for AWS Shield. So today we're going to go over some DDoS threats and trends. We'll discuss the AWS approach to DDoS mitigation. We'll go over the differences between Shield Standard and Shield Advanced. I'll cover some referenced architectures, and we'll review some best practices for protecting your game servers. And we'll wrap things up with a live demo. So when discussing DDoS protection and your security footprint, it's best to separate different types of threats. And we'll be focusing on the distributed denial of services and how they can affect your game servers. We break up these threats into two different categories: application floods and network and transport layer floods. The difference is that the application layer floods can be more sophisticated and target weaknesses in your application's delivery chain, while transport and network layer attacks are designed to saturate the availability of network resources to your game servers. If you've had any sort of experience with these attacks, you know that they can affect not only you, but maybe other customers or partners in your delivery, or even the network that your application resides on. Application attacks typically target some resource in your application, like a backend database or a login service, and it can be difficult to distinguish real clients from the attackers. Over the years, these attacks have gotten much larger. You're probably familiar with the Mirai attacks in 2016, which registered around a terabit per second and hit some of the largest network providers around the world. Earlier this year, we saw a new record breaking past 1 terabit per second. And it was a Memcached attack, which was kind of taking advantage of Memcache servers and causing them to reflect very large responses at unwitting targets. And so you can see that this is becoming a bigger problem for game providers because of the interactive and real-time nature of multiplayer games. At AWS, we like to give customers a real-time view into the threat landscape, and I'll show you that later in the live demo. So why is this important as a game provider? Well, obviously the availability can be impacted, which degrades experience for our players. And attacks can last for hours or even days. There can be financial impact, which can impact your ability to conduct microtransactions, or if you're a subscription service, you can lose subscribers permanently. A DDoS attack can also affect the reputation of your service in terms of availability or even the integrity of the data, because sometimes these attacks can be used as a distraction while a break-in attempt or a data leak is being executed simultaneously. So let's talk about some of the traditional challenges of DDoS mitigation. First is that it can be difficult to set up. If you operate a network and are running a game on that network, you have to have additional capacity, right? So you have to have overhead to make sure you can absorb these attacks without having congestion on your network. Sometimes it'll even require you to re-architect your applications to handle multiple entry points for your network traffic. Incident response can be troublesome because it can take minutes before you're even aware of the impact, and then you're chasing down different types of metrics or activating countermeasures or protections. Performance can be degraded during an active mitigation depending on the size and scale of your mitigation approach, and this can be this problem is exacerbated in a gaming environment where milliseconds matter. It's different from, say, a web application where you can sometimes overcome the nature of the attack by caching static content or sharding the service out to more endpoints. But as you know, in multiplayer games, oftentimes you're restricted to a specific endpoint where multiplayer services have to communicate to the same server. Time to mitigate is an important metric, which can be challenging unless you're in a fully automated environment. Sometimes if an attack is happening against multiple endpoints or multiple customers or targets, you're waiting in line for a response team to take your case. And also it can be quite expensive. Different approaches can have you unsure of your mitigation budget. Maybe your cost model scales with the size of attack, or it scales with the amount of risk that you want to take on. And so let's talk about how at AWS we overcome these challenges. To frame things correctly, it's important to discuss the evolution of DDoS mitigation. And so when DDoS mitigation first started, your standard approach was to have an on-premise set of detection and mitigation appliances. And then the industry kind of moved to a cloud-routed solution. This is where you're moving traffic off network to a provider and kind of allowing economies of scale to reduce the operating or the capital cost of your solution, and maybe you're renting time at a mitigation center. At AWS, we've baked in these solutions and we call it cloud native. For the on-premise solutions, some of the challenges were around scaling. As your network grew, you would have to buy more capacity, so your overhead maintained, so you maintained enough overhead to handle attacks, and you would also have to buy these expensive appliances as you go. So for every time you added a new POP, or if you vertically scaled a point of presence, you were adding more appliances to make sure that every ingest point was protected. And also your visibility or control was limited to that which a vendor gave you in the appliance. With cloud-routed solution, that problem was solved, but the biggest setback with cloud-routed was probably latency. When you put another network in front of your network, you're at the mercy of that network's latency and then reliable routing between that intermediate network for mitigation and passing clean traffic back to your origin. The cloud-routed solutions could handle larger attacks because of the increased economy of scale, but it was still a black box solution which could introduce that latency, additional points of failure, and increased operating costs. So at Amazon, we've created AWS Shield, which is automatic and always on and can protect all of your applications. You'll be able to take advantage of every AWS region, all of the multiple transit centers providing internet access to those regions, and over 100 edge locations to mitigate attacks closest to the source. And so that's with services like Amazon CloudFront and Amazon Route 53. We've kept things simple and flexible and affordable. We follow all of the Amazon pricing tenets, so it scales as your utilization does, and you'll have all of the robust capabilities without having to do kind of uninteresting heavy lifting like installing appliances as you scale your application. And so one of the things that's important with AWS Shield is that we wanted to make sure it integrated directly with the services you use to build your application. So it's tightly integrated with things like ELB and EC2, Amazon CloudFront, Amazon Route 53, and you can continue to define your infrastructure as code and maintain your protection footprint. It's always on for both detection and mitigation, so you don't have to worry about responding to events or we launched a new title, we have a new game server rollout, is that protected or not? You can define that as code in your AWS environment and make sure you're always protected. It's affordable, so you don't have to worry about what size of an attack you can afford. There's a simple subscription model, and like all things at AWS, it scales as you utilize those services. And it's quite flexible, especially with Shield Advanced, and we'll get into some of the benefits of that as well. So up until this point, AWS Shield Standard, although not productized until early 2015, AWS has always had a practice and a discipline of detecting DDoS anomalies and protecting AWS services. So maintaining the availability of the underlying services at AWS, Amazon.com, and its subsidiaries. At reInvent in 2015, we launched the AWS Web Application Firewall, or WAF, with support for CloudFront and the Application Load Balancer. At reInvent in 2016, we launched Shield Advanced with support for CloudFront, Route 53, and ELB. And then last year, we added support for elastic IP addresses associated with EC2 instances and Network Load Balancer. This is really powerful for game providers because most of our applications aren't web-based, and if they are, they might use WebSockets. So for UDP protocols and streaming TCP applications where CloudFront and ALB may not apply, we were looking for the ability to protect elastic IP addresses directly. Let's get into Shield Standard and Advanced and the differences between them. Simply put, Shield Standard is built-in DDoS protection for everyone. If you're using Amazon Web Services, you're a Shield Standard user. whether it's a simple web application running on Beanstalk, or a single game instance running on an EC2 instance, or a CloudFront distribution protecting your retail environment. Shield Standard is protecting you. You'll get automatic defense against the most common network and transport layer attacks for any resource in any region. If you're using an edge service like Amazon CloudFront or Route 53, you'll have comprehensive defense against all types of attacks like SYN floods, UDP floods, and reflection attacks. Now, this covers the lower layers of the threat environment. That's layers 3 and 4. But what about application layers? Well, this is where AWS WAF comes in. AWS WAF is a standalone product, and if you're a Shield Standard user, you can combine that with AWS WAF to have a holistic approach to your security footprint. AWS WAF is a self-service pay-as-you-go model, so it scales with your utilization. Small applications with low traffic, AWS WAF is low cost, and it scales up as your application usage does. WAF today is available for Amazon CloudFront distributions and ALB instances. There are 3 popular deployment modes for AWS WAF. One is to build the rules yourself, which there's plenty of great documentation in the SA and the customer community sharing these rules. Another is the managed rules, which can be subscribed to through the AWS Marketplace. And these rules are created by our partners and sellers in the security space. And another one is through security automation. Our solutions architect community updates CloudFormation templates and shares them through AWS Answers and AWS Docs and community events to kind of give users a good starting point for building an automated WAF deployment. And this can cover things like your OWASP top 10 threats and mitigate attacks like SQL injection or cross-site scripting, basic reputation lists, and give you a good starting point. Or you can even use any combination of the above. You can subscribe to some rules that are specific to zero-day threats and add that to maybe a security automations template. So subscribing to the managed rules for AWS WAF is pretty straightforward. You pick the rule set that you want in the marketplace. You click subscribe, and then you associate it to a web ACL in your WAF console. So that's Shield Standard in a nutshell. Moving on to Shield Advanced. You're going to get enhanced protection, which is kind of a loaded term. It covers quite a bit of things. Protection at AWS can be broken down into 2 practices, detection and mitigation. So for detection, for Shield Advanced, we're actually able to detect layer 7 attacks. That's your HTTP floods, your DNS queries. We're able to baseline traffic against every resource you register with Shield Advanced and detect anomalies even if they're not necessarily a DDoS attack. This can be useful for deciding in the future whether or not something is an attack. You'll get enhanced layer 3 attack detection. What this means is instead of waiting for the underlying AWS service to reach some anomaly threshold, like packets per second reaching an instance at over 1 million, we actually understand what's normal for that resource and can recognize attack signatures against the resource. So instead of designed to maintain the availability of the underlying service for all customers, it's actually targeted at the availability of your application. And we also have the ability to set granular detection thresholds based on the type of resource, the family of the instance, the region that it's in, or how many of them you have in a scaling group, which is really powerful. And on the mitigation side, Amazon has built its own proprietary packet filtering stack. This stack is one of the most distributed systems at Amazon and exists at every point of presence around the world. So over 100 edge locations and nearly as many transit centers in our regions. We have many tens of terabits per second of capacity at the ready to scrub DDoS attacks before they enter the region. And the way that we scrub those packets is actually very smart. It uses a suspicion-based filtering mechanism. So instead of just dumb rate limiting, it's able to score traffic based on suspicion. It could be the source of the traffic, it can be the pattern of the traffic, the nature of the packet, the time of day even. And when mitigation is required in an automatic fashion, we're only dropping the most suspicious bits first. And that enables you to get the most amount of traffic at your instance without risking availability. The pre-configured mitigations according to resource type I mentioned earlier. Suppose you're using a C5 2x 8XL instance. Well, that's going to support far less packets per second than maybe an 8XL C5, right? So the larger your instance scales vertically, the more PPS you'll be able to handle. You'll have the ability to define your own mitigations in coordination with our DDoS response team. That's my team. And that team is also able to engage Amazon networking and do advanced traffic engineering. This is useful, for example, when you receive an attack that's so large, which this hasn't happened in practice, but we've game data and fire drilled it, and we're prepared to do it for Shield Advanced customers, Amazon.com, or any AWS service that is an internal customer. And that's the ability to move traffic around globally, even if that attack exceeds the physical capacity in a region. We can sort of spread that traffic around and sync it in other parts of the world. And another neat thing about Shield Advanced is when you define network ACLs for your VPC, those ACLs are actually pulled and executed at the border of the Amazon network during an active attack. And this allows you to keep unwanted traffic off of your instances, specifically for EIP resources like EC2 and NLB. So in the DDoS expertise category of Shield Advanced, you'll also have the ability to access the DDoS response team. This is a 24/7 team of DDoS mitigation experts that specialize in automation, tooling, and countermeasures. So some of the activities that you can engage the DRT for will be preemptive engagements. These are non-emergency activities, like a DDoS architecture review, where we can help you do a gap analysis and make architecture recommendations. Sometimes that's things like using CloudFront in front of a TCP ELB classic, or using different instance families or sizes in your game. And it's useful if you're whether you have an existing architecture or you're just looking to shore up gaps in your resiliency. We can do game days and fire drills and help customers test out any automation they have around the Shield metrics that are emitted into CloudWatch, which are really neat. I'll show you that in the demo. And we can create custom mitigation templates for EIPs. So suppose you have a specific application that's sensitive to certain types of attacks, or you have a known list of trusted partners that you want whitelisted out of any automatic mitigations that take place. We can build those templates for you, and they'll automatically be executed whenever there's a mitigation taking place. Now, in an emergency, the DRT is available for critical and urgent cases for Shield Advanced subscribers. We're automatically engaged anytime there's an availability impacting event Amazon-wide, which is very rare, but we do have that practice. And then there's customer-driven cases. That means you're able to open a support case, which results ultimately in a DRT operator joining a chime bridge and working with you directly to help you resolve a mitigation. We can do incident triaging if you have multiple attacks going on at once, and we can also be engaged to do manual traffic engineering. So that kind of wraps up the DDoS expertise portion of Shield Advanced. The next two areas that we break the service up into are visibility and compliance and economic benefits. Now, the visibility and compliance piece, we break that down into kind of three benefits that you'll get. And we give this to you in three different ways. One is through CloudWatch metrics. And if you're familiar with CloudWatch, CloudWatch allows you to get real-time metrics across different dimensions of your service, and then tie those metrics into alarms for alerting. Shield Advanced resources will emit 15 different metrics. One is a binary metric called attack detected, and that's a really powerful one for triggering things like engaging your operations team. You can automate Slack bots, or even just SNS topics if you want to trigger a pager. And then the other 14 metrics are per vector metrics, which indicate the size or severity of a specific attack. You also get diagnostic reports. These reports give you detailed information about an attack when it's happening, and I'll show you one of those in my demo. It has a lot of neat information like the top talkers, the sources, the samples of the requests, and they can be really useful when triaging an attack that may not have a fully automatic response. And then there's the Global Threat Environment Dashboard. This is only available to Shield Advanced subscribers, and it's a new feature that's pretty interesting. It'll show you a heat map of the globe and some real-time statistics about the threats that we see across the AWS landscape. So now I'm going to cover some of the economic benefits of Shield Advanced, right? So it's not just the ability to have a superior security posture, and not just the ability to see and maintain compliance when it comes to DDoS protection, but also AWS WAF is included for Shield Advanced subscribers at no additional cost. So all of the scaling and utility costs of WAF is included when you're a Shield Advanced subscriber and you're protecting that WAF protected resource in Shield Advanced. Also, AWS Firewall Manager, which is a new service, is included at no additional cost. And you get what's called cost protection for scaling. So what this means is when you get a scaling event as a result of a DDoS attack, you're eligible for credits to compensate you for that event. That could be an auto-scaling group, that could be DNS queries, that could be CloudFront traffic, whichever. We don't feel that our customers should have to pay for an attack this way, that your invoice isn't an attack vector. So Shield Advanced today is available in 8 different regions: US East 1, US West 2, US West 1, EU West 1, AP Northeast 1, AP Southeast 2, EU Central 1, and US East 2, and counting. Today we support 6 different services, and we recently added support for elastic IP addresses. Some of our customers taking advantage of Shield Advanced today: OK Magazine, Wall Street Journal, Pokemon, Pearson, Netflix, and Rovio. Now I'm going to cover a couple of common reference architectures we see when customers are enabling Shield Advanced for their platforms. So this is a pretty standard, could be a web or TCP application with EC2 instances fronted by an application load balancer. It's a pretty common design. When you front that load balancer with Amazon CloudFront and Route 53, and then activate AWS WAF, you'll see that the DDoS attack lands on the WAF, and the WAF is able to block layer 7 traffic if it's an application attack. And if it's a volumetric attack, then CloudFront will absorb that attack, keeping undue strain off of the ALB and off of your EC2 instances. Attacks like SYN floods and slow LoRa's attacks are mitigated by Amazon CloudFront, and metrics are emitted by CloudFront and Shield. The WAF will allow you to block or rate limit any malicious requests. And Route 53 is able to mitigate any DNS query floods or malformed request attacks or DNS validation attacks that could be targeting the availability of your domain resolution. So let's take a look at some session-based game architecture. Again, you're going to use a simplified model, but the idea would be you have some game servers or battle servers. They may or may not be fronted by an NLB, and you can associate the elastic IP address with either the NLB or the instance itself. So when you register that elastic IP address with Shield, then Shield is able to make sure that the DDoS attack doesn't actually reach the NLB or the EC2 instance. And so in many cases, the only change you might have to make to your environment is to switch from public IP addresses to elastic IP address, and then register that EIP ARN with the Shield API. So now I'm going to cover some best practices and what are the steps that you can take today to make sure that whether it's a new title you're launching or a game that you maintain now is protected from DDoS attacks using AWS Shield Advanced. So the first kind of checklist is, are all the internet-facing resources protected, right? So that includes your hosted zones, so your customers can resolve the resource, any CloudFront distributions that might be delivering game downloads or handling sign-up pages, any load balancers that might be handling login or social and matchmaking, and any directly exposed EC2 instances. Now I'll show you in my demo that bulk registration is supported by Shield Advanced, so it's actually quite easy to go through and register all of your resources with one API call or one click in the console. The second question you'll want to ask is, are you monitoring the right metrics? Right, and I went over the CloudWatch metrics already. You want to know when you're detecting an attack, and also how to connect those CloudWatch alarms to any operations side activities like paging the right team, or documenting a ticket or anything like that. And the third question you'll want to ask is what to do as the result of impact of an attack. How do I engage the DDoS response team? What are the right steps to take? How long will it take? And we'll show you how to do that. From the preemptive side of things, conduct readiness tests, have a fire drill call, do game days. We provide to Shield Advanced customers a Lambda script that we've created, which will open a support case for you. It will page in the DDoS response team directly to your support case, and it will include information about the resource and the attack. Another thing you can do is on that fire drill call, if you have specific operational needs for your game, perhaps different or multiple teams that need to be called in or paged in, we can maintain a custom runbook for you as a Shield Advanced subscriber. So when a DDoS attack does affect a critical service, we're paging in the right teams to the call. We can also simulate a Shield alarm on the fire drill call so you can see what it looks like when a DDoS attack is happening. So here is another best practice that it will be really helpful for game operators and game servers, and that's building a trust list. When users log into your game service, or they authenticate against your website, or they create an account, you can take that as an opportunity in your application workflow to save their source address to just a simple file in S3. So two things in the Shield Advanced workflow when you sign up are giving the DDoS response team access to your Shield resources, and you can even designate an S3 bucket where you might store things like trust lists, whitelists, blacklists, or even raw logs from your applications so the response team can parse through them in a critical event that might have a sophisticated attack and you need help parsing through those logs. So if you are in the practice of parsing your customer data, right, the source IP addresses that they're connecting to your service with, and dumping those into an S3 bucket, there's all sorts of automated techniques for using that information, like having the S3 bucket trigger a Lambda function. But at the very least, exporting that data to S3 can allow the DRT to, when we do our game day and fire drill call with you, to place those source addresses into a trusted, like a whitelist above the mitigation in the filter chain. And this will make sure that your customers closest to your game server are least likely to be impacted by any mitigation that's going on against a game server resource. And so this is kind of like a neat best practice that we've found helps game server customers. Okay, so now I'm going to give a live demonstration of AWS Shield Advanced and show you what the inside of the console looks like and register some resources right now. Okay, so I'm going to go ahead and start off at the Shield and WAF console. Now, if you haven't subscribed to Shield, when you click on the protected resources link, you'll get a splash page kind of allowing you to sign up for and commit to Shield Advanced. But since this account already has Shield Advanced subscribed, you're taken to a summary of your protected resources. And you can see that I'm protecting one load balancer, 2 CloudFront distributions, and 1 hosted zone. So I almost have total protection. I've not protected my game servers, and I have a couple of elastic IP addresses that I'm going to protect right now. I'll show you how easy that is. You'll click on Add Protected Resource, and Shield is going to scan your account and look for resources that are protectable. And you see that I actually do have one more CloudFront distribution that I've not protected. I'm not going to protect that one just yet, but I'm going to choose region, and under region you have region global, and this is where your Route 53 hosted zones or your CloudFront distributions will appear. And then it's also able to scan all of your regions that might have regional protectable resources like ALBs, ELBs, or EIPs. And so if I click on US East and then enable elastic IP address, you can see my 2 game server IPs here. So I'm going to go ahead and check the box. You also have the ability to enter in the orange directly if you have a list of them. But we'll go ahead and use the wizard. I'm going to check the box for both of them and click Protect Resources. And here they are added to my manifest of protected resources. And you can see that we have network attack visibility and network attack mitigation. Now for web attack visibility and mitigation, this is going to be limited to anything that can be associated with a web ACL. And web ACLs are how you protect web applications using AWS WAF. Now this is the WAF and Shield console. So I'll take a moment to kind of show you the how that's done before moving on with some of the other Shield Advanced features. So in WAF, you have these web ACLs, which are essentially lists of rules and rule sets. And once you have rules and rule sets, you can then associate the web ACL with a resource like a CloudFront distribution or an application load balancer. If you don't want to write those rules yourself, you can use the marketplace here. And you see we have a list of sellers which are selling managed rule sets and different rule sets for different types of applications. Some for specific web applications, some for zero-day threats. And these are all trusted partners in the AWS marketplace. So back to my protected resources. Now you see I have 2 elastic IP addresses protected. And I do have 1 attack in the last 6 hours. This gives you a little histogram of any attacks you've had recently. We can actually dive down and click on incidents. And you can see that I've got a history of attacks against a couple of my CloudFront distributions. They're typically UDP traffic. And CloudFront is really good at protecting against these types of attacks because it's a web-based service, so it just drops UDP traffic entirely. You can see that I had an attack on April 13th in the middle of the day that lasted about 6 minutes. And there's a quick link here to take you to the CloudWatch metric. And you can see there's 1 data point. Let me zoom in on it. Here it is. And so there's 1 data point, and the attack was around 14.5 gigs of traffic. And then there's the DDoS attack bits per second. And you can map these metrics to alarms and then take actions off of those alarms. So you can see I have one for DDoS attack detected, and I have no action set, but you could map this to an SNS topic, to an auto-scaling event, and there are different partners that actually support CloudWatch integration that you can take action with, which is kind of neat. And so also when you click on the resource name, it'll take you to the attack details page too. And I don't have any details for this attack because these are simulated attacks. I'm not actually launching attacks against my resources, but it'll actually show you the CloudWatch metric and details about the attack. And so this is a really cool feature called the Global Threat Environment Dashboard. And what it does is it pulls near real-time data. It's updated multiple times per day, and it allows you to pull metrics about the Amazon threat environment globally over the last day, 2 weeks or 3 days. And so we'll go ahead and pull the 2-week numbers, and you can see that it'll tell you the the hotspot in this case is actually that looks like EU West 1. Most of the time I see it here in US East 1, but you can kind of look at where the hotspots are, and this heat map is a smart map, and it will kind of scale relative to the size of the region. You can see how many attacks were observed. Now this is just attacks against known customer resources. It doesn't include attacks that just land on AWS randomly. So this means we've actually mapped out 16,892 attacks against customers. The largest one observed in the last 2 weeks was 89 million packets per second. The largest bit rate was 220 gigabits per second, this type of thing across all the different vectors. And even tells you the most common vector. This threat level field is kind of special. This is basically determined mathematically, and when there's a substantial uptick in threat overall to AWS, this might change to high and be bundled with some kind of threat advisory that's accessible to Shield Advanced customers. You can see a histogram of all the quantity or frequency of attacks over the last 24 hours, and then a breakdown by unit type. So for packets per second, bits per second, and even requests per second for customers who do have layer 7 mitigation enabled. And so removing a protected resource is really straightforward. You click on the resource and click delete protection. It cannot be undone, and any attacks against that resource will not be detected by Shield Advanced. It effectively becomes a Shield standard protected resource at that time. And you can see it's that easy to do. I can go in there and delete the protection. And with that, I want to thank you for attending our webinar. This is a link for the Getting Started guide for Shield Advanced, which will take you through many of the steps we went over today and more. My name is Sean Mark with the DDoS Response Team. Thanks.